Hello?
Yes, sir.
Can you see what I am writing? Is it visible
Visible.
clearly?
Yes.
Can you solve this problem, sir? Our target is to do 20 problems, mind you. Problem number 1. A bivalent metal electrochemical equivalent is equal to 0.00012 grams per coulomb. What is its atomic weight? To solve this problem, I should know that according to Faraday's first law, what is the Faraday's first law, sir? According to Faraday's first law, mass of any element produced during electrolysis is equal to EIT. In that, what is E, sir? Electrochemical
Electrochemical equivalent.
equivalent. It tells us the mass of the element produced for 1 coulomb charge, where I is 1 ampere, time is 1 second. Therefore, mass of an element produced for passage of 1 coulomb is 0.0012 grams per coulomb. That is E. Do we know that the mass of the element produced for 96,500 coulombs is equal to its chemical equivalent weight? Do you know that, sir? So what is the chemical equivalent weight of this element? The electrochemical equivalent into 96,500. Are we very clear, sir? Hello? Hello?
Yes, sir.
Please notice, sir, electrochemical equivalent is mass released for 1 coulomb. Ordinary chemical equivalent is mass released for 96,500 coulombs. So the chemical equivalent weight of this element is nearly equal to 96,500 into 0.0012. Can you make the calculation using your calculator? It will be close to 12. Sir, if you don't have time, take 96,500 as 10 to the power 5. Can we take check that, sir? Hello? It works out to be 12. You know that atomic weight is equal to valency into chemical equivalent. చూడండి, మన క్లాస్ లో ఉన్న ఒక్క క్షణం ఆగిస్తా. So atomic weight is equal to valency into equivalent weight. The valency is 2 because in the problem they said it is a bivalent metal. So 2 into 12, atomic weight is equal to 24. There are 3 ideas I want every student to kindly notice. When I am passing current through an electrolyte, different elements are produced at cathode and anode. At anode, somebody will lose electrons. At cathode, at anode, there is loss of electrons. At cathode, somebody will gain electrons. So you get different substances at cathode and anode. But notice, for passage of 1 coulomb of charge, always I get a mass of element which is equal to its electrochemical equivalent. For the passage of 96,500 coulombs, the mass of the element I get is called its chemical equivalent. So if they give me E value, multiply it with 96,500 to get a chemical equivalent. Always chemical equivalent into valency of that element is equal to atomic weight. Are we very clear about this model, sir?
Yes.
Hello? Sir, I should remember three relations to solve problems on Faraday's laws. First relation I should remember is M is equal to EIT. Mass of an element produced during electrolysis is equal to its electrochemical equivalent into current strength in amperes into time in seconds. Second point I should remember is when the same charge is maintained through different electrolytes, then M1 by M2, mass of one element produced by mass of second element produced, is equal to equivalent weight of first element divided by equivalent weight of second element. By equivalent weight, I mean the atomic weight of the element divided by valency. Also, equivalent weight is equal to molecular weight of an acid divided by the number of H plus ions acid molecule can give. Equivalent weight of KMnO4 in acidic medium. When KMnO4 in acidic medium is gaining 5 electrons, then the equivalent weight of KMnO4 is molecular weight by 5. Number of electrons gained by each molecule, that is called N factor. Therefore, equivalent weight of any substance can be worked out. You know how to work out the equivalent weight of H2SO4, sir? Equivalent weight of H2SO4 is equal to molecular weight of H2SO4 by 2. Why are you putting 2? Because each H2SO4 can give 2H plus. It is called its basicity or N factor. For HCl, what is equivalent weight means? Simply it is equal to molecular weight by 1. Why 1? Because it gives only 1 H plus. Equivalent weight must be understood very clearly. If the KMnO4, which is having manganese in +7 state, is becoming Mn plus 2, it means +7 is gaining 5 electrons in acidic medium, then its equivalent weight is equal to molecular weight by 5. If the same KMnO4 in basic medium is becoming just MnO2, here manganese is +4. When +7 is becoming +4, it is gaining 3 electrons. If it is gaining 3 electrons, in this case, in basic medium, equivalent weight of KMnO4 is equal to molecular weight by 3. Whatever the way you calculate equivalent weight, one equivalent weight of any element or one chemical equivalent weight of any element is produced for the passage of 96,500 coulombs or 1 Faraday charge or the passage of Avogadro number of electrons. Charge corresponding to 1 mole or Avogadro number of electrons is obtained by multiplying 1 mole with charge of electron. If you do multiplication, you will be getting 96,500 coulombs. So notice, whenever I pass 96,500 coulombs or 1 Faraday charge, or whenever I pass Avogadro number of electrons through any solution, I will be getting 1 chemically equivalent weight of any element. If I know that, I can clearly understand 1 Faraday of charge can always give me 1 gram of hydrogen. 1 Faraday of charge can give me 8 grams of oxygen, because equivalent weight of oxygen is atomic weight 16 by 2, because oxygen always takes 2 negative charges. It can also give me 9 grams of aluminum, because aluminum is +3 usually. Atomic weight 27 by 3, that is 9 grams. Notice that it gives me 35.5 grams of chlorine. During electrolysis, this is the rule. Do you know 1 gram of hydrogen means half mole of H2 gas, because H2 molecular weight is 2, 1 gram means half mole. Half mole of any gas at STP or NTP occupies 11.2 liters. So the volume of hydrogen gas produced during the electrolysis of acidified water, 11.2 liters at STP. For passage of 1 Faraday, through acidified water, I get 1 gram of hydrogen or 11.2 liters at STP. STP or NTP both mean same. If you are looking at oxygen, when acidified water is subjected with 1 Faraday charge, I will be getting 5.6 liters of oxygen at STP or NTP. NTP means normal temperature and pressure. STP means standard temperature and pressure. Both are same. So sometimes they can ask, when acidified water is subjected to 2 Faraday's charge, what is the volume of hydrogen produced? For 1 Faraday, we get 11.2 liters. For 2 Faradays, you get 22.4 liters. If you pass 2 Faradays of charge, for 1 Faraday, I will be getting 5.6 liters oxygen. For 2 Faradays, I get 11.2 liters. Once in IITG, they asked, to completely dissociate 1 mole of water, how many Faradays of charge is needed? Sir, 1 mole of water you want to dissociate it. So, water should become H2 gas and off O2 gas. In this process, the 2H plus have to gain 2 electrons and the O minus 2 should lose 2 electrons. Can you see it, sir, clearly? Hello? Because in H2O2 hydrogens are 2H plus. In H2O, 1 oxygen is O minus 2. During electrolysis, O minus 2 should lose 2 electrons at anode. During electrolysis, 2H plus should gain 2 electrons at cathode. Pure water cannot pass current, so you should add a little bit acid. When acidified water is subjected to electrolysis, always 1 mole will give 1 H2 of O2. To give 1 H2 and to give 1 half O2, how many electrons are transferred? 2 moles. You know, charge of 1 mole of electrons is 1 Faraday. So charge of 2 moles of electrons is how much, sir? 1 mole electrons charge is 1 Faraday. 2 moles electron charge is
2 Faraday.
Therefore, to completely dissociate 1 mole of water, how many Faradays of charge is needed?
2 Faraday.
How many? 2 Faradays. Are we very clear about it, sir?
Yes.
To completely dissociate 1 mole of water, I have to convert 2 H plus into H2. I have to convert 1 O minus 2 into off O2. It needs 2 moles of electrons flow. That is 2 Faradays. Are we very clear, sir? Hello?
Yes, sir.
So on Faraday's laws, whatever the problems they ask, if you apply a little common sense, you can happily solve. See this, each gram silver is 50 rupees. I want to quote 10 centimeters long, 10 centimeters wide copper plate with 0.1 centimeter thick silver. If silver density is 10.8 grams per centimeter cube, what could be the cost? How many Faradays charge is needed? Can you solve it, sir? Hello? There are 2 problems in this, sir. Each gram of silver is 50 rupees. Now I want to quote 10 centimeters long, 10 centimeters wide copper plate with 0.1 centimeter thickness silver by using silver nitrate and passing current. Now, if silver density is equal to 10.8 grams per centimeter cube, what could be the cost of silver? How many Faradays of charge is needed? Did you understand this problem clearly, sir?
Yes, sir. That's
Sir, now if you want to quote silver, you should have a setup where I will show you one diagram.
Copper is cathode.
What you do is, you make a setup like this. Can you see the paper slip, sir? Is it visible or blurred?
Visible.
Sir, this is a container where I kept a copper plate which I want to coat. The
Where
copper plate which I
camera
want to
is
coat with silver is to be taken as cathode. I will buy pure silver rod, use it as anode. I take silver nitrate solution as electrolyte. Through this aqua silver nitrate solution, I have taken silver rod as anode. Copper plate which I want to coat, I have taken it as cathode. When I pass current, at anode silver dissolves, at cathode it gets deposited. Now, whatever the theory, at anode actually the silver is dissolving by losing one electron. At cathode, the silver is getting deposited. Okay. Now my point is, sir, you want to have 10 into 10 into 0.1. So it is equal to how much, sir? 10 centimeter cube. Can you see, sir? It is 10 centimeter long. It is 10 centimeter wide. It is 0.1 centimeter thickness. So if I multiply, the volume of silver I require is 10 centimeter cube. You know density is equal to mass by volume. From this, what is the mass of silver I need, sir? Density into volume. What is the density of silver they gave me? 10.8 grams per centimeter. Into what is the volume I require? 10 centimeter. If I multiply the density with volume, I will be getting mass of silver. What mass of silver I require, sir?
108 grams.
Now, sir, for silver, atomic weight is equal to 108. In silver nitrate, silver charge is +1. Therefore, for silver, equivalent weight is also equal to 108 because 108 by 1 is equal to 108. Can you see it clearly, sir?
Yes, sir.
Yes,
So
sir.
if I want to deposit one equivalent weight of silver, I need to pass one Faraday charge. Secondly, cost of silver, they said 1 gram is equal to 50 rupees. So 108 grams is equal to how much, sir? Did I say 1 gram is equal to 50 rupees? Hello? 1 gram is equal to 50 rupees. 108 grams is equal to how much, sir? Hello?
108 into 50.
So 108 into 50, that is equal to?
5,400.
Is it 5,400 or 54,000?
Sir, 5,400.
Very good. You can see that 108. If you multiply with 100, you have to put 2 zeros. If you are multiplying with 50, divide with 2. It's 5,400 rupees. Are you very clean, sir? Hello?
Yes.
Yes, sir.
Clear.
Sir, this is standard IIT problem related to Faraday's laws. Other problems which I have seen are in an electrolysis experiment, I got 18 grams of aluminum. When the same charge is passed through calcium chloride, hello,
Yes.
Yes, sir.
when the
Yes,
same
sir.
charge is passed through fused calcium chloride, what mass of calcium is deposited? So I got 18 grams of aluminum by passing current through fused AlCl3. Fused, I have molten it and passed current. I got 18 grams of aluminum. Now the same amount of charge is passed through fused CaCl2. What mass of calcium is deposited? So mass of aluminum deposited by mass of calcium deposited is equal to equivalent weight of aluminum divided by equivalent weight of calcium. Any problem, sir? This is according to Faraday's second law. So I got 18 grams of aluminum divided by mass of calcium deposited, I don't know, is equal to, you know, equivalent weight of aluminum is 9 and equivalent weight of calcium is atomic weight by 2. You know, atomic weight of calcium is 40. Do we know, sir?
Yes, sir.
So this is 20. So 18 grams of aluminum by m grams of calcium is equal to 90 by 20. Therefore, mass of calcium is equal to 18 into 20
40.
by 9. So you'll be getting how much, sir?
40.
40 grams.
Sir, sometimes they will say, I got in an experiment by passing certain charge through fused calcium chloride and I got 80 grams calcium. When the same charge is passed through acidified water, what volume of a hydrogen is produced? Yet tasting. Now they are relating to volumes. I will use the first formula. The mass of calcium deposited by mass of hydrogen produced is equal to equivalent weight of calcium by equivalent weight of hydrogen. So what is the mass of hydrogen I am getting, sir?
4 grams.
Now you know that hydrogen molecular weight is 2. 2 grams is 22.4 liters. 4 grams is equal to 44.8 liters. Can we see it, sir?
Yes, sir.
Hello?
Yes.
So whatever the problem they ask on Paradise is usually based on these ideas. What ideas? I should remember that mass is equal to EIT, where E is called electrochemical equivalent, I is called amperage, T is called time in seconds. Sometimes they say, I passed 5 amperes current for 2 hours. What mass of silver is deposited if I pass 5 amperes of current for 2 hours? And if the electrochemical equivalent of this metal silver is 1 into 10 to the power minus 4. Notice that if you want to know the mass of silver deposited, when the electrochemical equivalent of silver is 1 into 10 to the power minus 4 grams per coulomb, for the passage of 5 amperes, in 2 hours, convert the hours into seconds. 2 into 60 minutes into 60. These are the seconds. If you multiply, you get the mass of silver. Sometimes they say, my current is only 25% efficient, then what mass I will get? If your current is 25% efficient, in fact, even if you are passing 5 amperes, it is not 5 amperes because it is not 100% efficient. Therefore, if current is, say, what percentage efficient you said, sir? Hello.
25.
25.
25% efficient. What you will do is mass of silver deposited is equal to electrochemical equivalent into amperage into 25% into 2 hours. 2 into 60 into 60. So if the current strength is multiplied with percentage efficiency, you will be getting real current. That way you solve. So any problem they ask on Faraday's laws, you are able to solve. You remember, whenever a costly metal is coated on a cheap metal, costly metal is to be taken as anode. Cheap metal on which you want to coat is to be taken as cathode. The costly metal salt solution is taken as electrolyte. Also remember, in aqueous solution, all the 3D series elements have negative electrode potentials except copper. Only copper electrode potential, Cu plus 2 by Cu, is positive. In 3D series, only element that has positive electrode potential is copper. Therefore, in aqueous solution, only copper plus 2 can undergo reduction to give copper metal. The first group metals like zinc ions, they can't take electrons to become zinc in water solution because the zinc electrode potential is negative. Negative means its value is minus 0.76. Therefore, all the fellows who have negative potentials in aqueous solution cannot take electrons. It is the water that takes electrons to become hydrogen gas. Therefore, if I have a solution that contains zinc ions in water, zinc ions will never take electrons. This is the water that takes electron to become hydrogen at cathode. If I have a solution that contains zinc ions, copper ions, silver ions in water, which ions are reduced first? the silver ions are reduced first because the electrode potential of silver is higher. Higher is the reduction potential, more readily it is reduced. After silver, which is reduced, copper. After copper, which is reduced, can you say after copper, which is reduced, sir? Hello? Sir, an
Zinc.
aqueous solution contain zinc ions, copper ions, silver ions. Can you tell me what are the fellows who are getting reduced when you pass current? First is silver.
Silver, sir.
When all the silver became
What is it?
silver metal, next is copper plus. When all copper plus became copper, what is the third fellow that is reduced, sir? Hello? What is the third fellow that is reduced, sir? Hello?
Zinc.
Zinc is never reduced, sir. It is the water that is reduced to give hydrogen gas. Zinc is never reduced because zinc metal's reduction potential is negative, minus 0.76. All the elements whose electrode potentials are largely negative, like zinc, like aluminum, like calcium, like sodium, they will never take electrons if there is water, because water whose electrode potential is higher than these fellows will gain electrons to become hydrogen. So is it possible to get sodium metal by electrolysis of NaCl aqueous solution? If you pass current through NaCl aqueous solution, can you get sodium metal, sir?
No, sir.
You will never get sodium metal because all first group metals electrode potentials are largely negative. In fact, lithium has highest negative reduction potential. So lithium plus would never gain electrons in water. Always this is the water that gains electrons. Are we very clear about it, sir? Hello?
Yes, sir.
Yes.
So about Faraday's laws, I tried to give you some clarity in this class. You got the clarity?
Yes.
Now I am going to cells. Please ask me any doubts. We have a lot of time. All the time in the universe is with us. We are not in pressure. Slowly. When I pass current through some solutions, they undergo dissociation and they undergo a chemical chain. At anode, somebody will lose electron oxidation. At cathode, somebody will gain electron reduction. Such solutions are called electrolytes. All strong acids like H2SO4, like HCl, all they are good electrolytes. All strong bases like NaOH, KOH are very good electrolytes. All the salts formed either by a strong acid or by a strong base or by both strong acid, strong base, any one strong or both strong. Such salt solutions are also very good electrolytes. But weak acids like acetic acid, that is a weak electrolyte. Ammonium hydroxide is a weak electrolyte. Sir, if I take a salt of acetic acid, which is a weak acid, with NaOH, that is a strong base. Salt of acetic acid and NaOH is sodium acetate. What is the nature of sodium acetate in water? It is an excellent electrolyte. Notice, if the salt is coming at least from one strong component, if the base is strong or if the acid is strong, any one is strong, then that salt solution is a good electrolyte. Do you know, sir, NaCl is a salt formed from an acid and a base? Do we know? Sir, NaCl is formed from which acid, which base? Can you tell?
NaOH.
HCl plus
It is
NaOH.
the strong base NaOH. It is the strong acid
HCl.
HCl. Therefore, the salt in water solution is an excellent electrolyte. When salt is dissolved in water, it conducts current beautifully. The chloride ions lose electron to become chlorine gas. And the sodium ions try to gain electron, but unfortunately they can't gain electrons because the Na plus electrode potential is very low. It is the water that gains electrons to become hydrogen gas and OH minus. That OH minus combines with Na plus to give NaOH. Thus, when salt solution is subjected to electrolysis, you get chlorine at anode, NaOH at cathode, hydrogen gas at cathode. Na plus is not taking electrons. Do we know about this, sir?
Yes.
Hello? Sir, if I want to make sodium metal by electrolysis, there should not be any water. Then can I pass current through solid NaCl? You cannot pass current through solid NaCl. In solid state, ions cannot move. Ionic compounds cannot allow current to pass. So through water NaCl, if I pass, sodium plus cannot take electron, water takes electron. Through solid NaCl, if I want to pass current, I cannot pass. Now what should I do, sir? What should I do? I should melt the NaCl by heating. That fused mass is subjected to electrolysis. Then there is no way. Na plus is the only fellow which has positive charge. Now that will take electron to become sodium metal. Cl minus is the only fellow that has negative charge. So that fellow will lose electron. Cl minus will become chlorine gas. Na plus will become sodium metal. So in order to get sodium, potassium, calcium, rubidium, cesium, aluminum, all the reactive metals of first group, second group, third group, I should take their salts fused mass and specially design a cell and pass current to get those elements. So that is a note on that. Are we clear about all these ideas?
Yes.
Sir, now we are talking so far about cells which needed electric current. They are consuming electric current to bring about a reaction for which delta G is positive. The reaction is non-spontaneous. NaCl to break into sodium metal and chlorine will never happen by itself. It will never happen. So you are forcing this reaction to happen by using current. Such reactions delta G is positive. So reactions which have delta G positive, which are not favored, are made possible by passing current, electric current. Are we clear on this, sir? Hello?
Yes.
Yes.
Sir, in my mobile charge is going to switch off any moment. Then I will start my class in another tab. If the class gets, stopped in between, then we will be rejoining. You will be continuing there. I will open it in another tab. So don't go away. May I request you to kindly stay. This class is very important. For me, it is important. I want to do as many problems as possible. I kindly request to bear with it. Will you please? Hello?
Yes.
Sir, now I am going to talk about the impossible reactions which don't happen by themselves. You are using electric current to bring about. Now, if you want to generate electric current, then if you want to generate electric current, you should carry out a reaction that is likely to happen. For example, zinc is likely to lose electrons to copper plus 2. If you have blue color copper ions in aqueous solution, if you add zinc, urgently zinc will lose electrons to become Zn plus 2, and the blue color copper ions will become red color copper. This is a reaction that happens by itself. So directly if you put zinc pieces in copper sulfate, solution blue color changes to red color and solution will become hot. So you don't allow them to react directly. Instead, you take a zinc rod in a zinc sulfate solution. You take copper solutions, copper plus 2 ion solution, put a copper rod, and you connect these two fellows. You can put a bulb here. If you do so, sir, the zinc is trying to lose electrons, and these electrons will pass through the circuit. Here in this compartment, the copper plus 2 will take those 2 electrons to become copper metal. So if you separate the fellow who is losing electrons from the fellow who wants to take electrons, if you allow these electrons to travel through a circuit, you can generate electric current. Notice, if you directly react, no electric current is produced. Simply solution will become hot. So you should separate the fellow who wants to lose electron with the fellow who wants to gain electron. You should connect these two fellows. When you do so, the zinc electrons will travel through the circuit and they are given to copper plus 2, copper gets deposited. To ensure smooth flow of current, here you are putting a salt bridge. This cell is called electrochemical cell, which I represent like this. The zinc, which is becoming zinc plus 2, that is connected with the help of a salt bridge to copper plus 2, which is immersed in copper. Copper plus 2 is trying to become copper, zinc is becoming Zn plus 2. Are we very clear about it, sir?
Yes,
Now,
sir.
under normal standard conditions, I put it 1 molar, I put it 1 molar, I put it temperature 298 K. Then this cell which I am making in this way is called standard cell, and its potential is always equal to E right minus E left. That is E cathode, this is cathode, minus E anode. This is notation always that is to be formed. Notice that the electrode potential of zinc or copper or anybody is measured by linking it with hydrogen electrode. The standard hydrogen electrode is made by passing hydrogen gas at 1 atmosphere pressure into a solution that is having H plus ions in 1 molar concentration. If the concentration H plus ions is 1 molar, the pH of this solution is equal to 0. Sir, under standard condition 298 K, I have to maintain hydrogen gas at 1 atmosphere. I should put it in H plus ions whose concentration is 1 molar. Sir, if I am changing the pressure of hydrogen, then that is not a standard hydrogen electrode. If I am changing the concentration of H plus, that is not standard. If that is not standard, simply I call it as hydrogen electrode. Notice, standard hydrogen electrode potential is taken as 0. But if you are not maintaining standard, if you are changing the pressure, or if you are changing the H plus ion concentration, it is not a standard hydrogen electrode. Now, what is the hydrogen electrode potential? What is the hydrogen electrode potential? If pH is equal to, say, 3. Notice that if you are changing pH, hydrogen electrode potential changes as minus of 0.059 into pH. That is a formula obtained from what is called a Nernst equation. Notice that when a hydrogen is actually losing electrons, it is producing H plus ions. Sir, if you are decreasing the H plus ion concentration, if you are decreasing the H plus ion concentration, pH will increase. When you are increasing the pH, the hydrogen electrode potential will become more and more and more negative. When hydrogen electrode potential will become negative, when I decrease H plus. When I decrease H plus, what happens? The pH will increase. Are we very clear, sir? Hello?
Yes, sir.
On the contrary, if I increase the pressure of hydrogen gas, if I am increasing the pressure of hydrogen gas, it tries to lose electrons. Yes or no, sir? Yes or no? Yes or no?
Yes.
I am keeping 1 molar H plus, no doubt, but instead of putting hydrogen gas at 1 atmosphere, I take 2 atmosphere. I take 3 atmosphere. By increasing the pressure of hydrogen gas, I am forcing the hydrogen to lose electrons. In that way also, the hydrogen electrode potential will become negative. So by doing what I can make hydrogen electrode potential, either by decreasing H plus. Decreasing H plus means, if H plus is 1 molar, pH is 0. If H plus is decreased, I am making H plus as 0.1 molar. If H plus became 0.1 molar, it can be written as 10 to the power minus 1. Then the pH is equal to minus log of 10 to the power minus 1. That is 1. Original pH 0 became 1. If I am increasing the pH to 1, 2, 3, 4, 5, pH is increasing. Solution H plus ion concentration is increasing or decreasing?
Increasing.
when pH is increasing or when H plus ion concentration is decreasing, then the hydrogen electrode potential becomes more and more negative. If I want to fix the H plus as 1 molar, if I want to make hydrogen electrode potential negative, the other option is increase the pressure. So this is a very important message. Now notice that in any standard cell, cell potential is given by E0 cell is equal to E right minus E left. Do you know that very clearly, sir?
Yes.
Sir, in a standard cell potential, I am assuming that I am taking all the electrodes in standard condition of 1 molar, even copper plus 2 is 1 molar, and this is the setup. But if I change the concentration, or if I change the temperature from 298 to some different temperature, the electrode potential under new condition is different from standard cell potential. In what way it is different is given by Nernst equation. Students should very clearly understand, by taking the cell under standard condition, I get standard cell potential. If I change the temperature condition or concentration condition, the cell potential would change. How it will change is given by Nernst equation, which says E cell is equal to E0 cell minus of 2.303 or T by NF into log product ions. Here, these are product ions concentration. By these are the reactant ions. Notice, sir, the log Zn plus 2 by Cu plus 2 is called equilibrium constant. Therefore, E cell is always equal to E0 cell minus of, if I simplify this using standard temperature and Faraday value, 0.059 by N into log K. It is to be understood very clearly. This is the formula I will use, where N is the number of moles of electrons involved in the process. Here the number of electrons involved is 2. I see the number of electrons involved in the equation. K is called equilibrium constant. Always remember, when a cell is non-operative, the cell potential becomes 0. When the cell potential becomes 0, we say the battery is dead and we throw it. When the cell potential becomes 0, obviously E0 cell is equal to 0.059 by N into log K. From this relation, can I find what is log K, sir? Hello?
Yes, sir.
If I know log K, if log K is equal to 15.6 minus of, then what is K, sir? K is equal to what, sir? What is the K value, sir? Suppose log K is equal to, let us take two cases. Log K is equal to 15.6. Then what is K equal to, sir? K is equal to anti-log of 0.6. Anti-log of 0.6 is 4. This is to be written as 10 to the power 15. Are we very clean, sir? Hello?
Yes.
Sir, sometimes you get log K is equal to minus 15.6. Then K is equal to. Sir, this is called characteristic. This is called mantis. Okay, sir? I say before decimal point, whatever is there is called characteristic. After decimal point, whatever is there is called mantis. Sir, if I write 5.234, what is characteristic?
5,
What is mantis?
2, 3, 4.
Ladies and gentlemen, in mathematics, there is a rule. In any logarithmic value, the characteristic can be negative, but mantissa cannot be negative. If I write log K is equal to minus 15.6, I am saying both 15 and 6 both are minus. But my rule is, this can be negative, this cannot be negative, because there cannot be any negative number. So what should I do, sir? I want to find K, but I got an
Minus
expression
15
log
plus
K is equal to
0.6.
minus 15.6. Sir, what I will do is, I will write log K is equal to, I will subtract 1. If I subtract 1 from minus 15, it will become minus 16. Any problem, sir? Hello, sir?
No, sir.
No.
Now I will add 1. When I add 1 to 0.6, it will become plus 4. Can you see? Plus 0.4. Can you see it, sir? Hello?
Yes.
Sir, whenever I have log k is equal to minus 18.3, I know that this can be negative, this cannot be negative. So to overcome this problem in my mind, what I will do is, I subtract 1 from characteristic point. I add 1 to mantissa, it will become plus 0.7. Can you see it, sir? Yes, sir? Now I will see antilog of this value. You know, antilog of here 0.4 is equal to some 2.6. Then this 10 minus 16 is to be written as 10 to the power minus 16. You understood? Try to simplify this, sir. I am giving you log 2 is equal to 0.3010. Antilog of 0.3010 is 2. Log 3 is equal to 0.4771. Antilog of 0.4771 is 3. Log 4 is equal to 0.6021. Antilog of 0.60 is 4. Log 5 is equal to 0.6990. Antilog of 0.69 is equal to 5. If you know this, let us find out. You know, log k is equal to, say, minus 13.5229. Sir, what is k equal to, sir? To find what is k equal to mathematically, what I will do is, sir,
Minus
this
14.
entire fellow is minus charge, which I don't want. I will subtract 1 from it, it will become minus 14. That's okay. For this minus value, I am adding plus 1. When I add plus 1, how much it will become, sir? Plus point. How much it will become, sir?
4,731.
400.
31. 71, yes, sir.
Sir, 0.4771. I want to remove log means I should see antilog of this. What is antilog of 0.4771? Whenever I want to remove log, I should see antilogs of it. What is antilog of 0.4771? Here I have written.
3.
Log 3 is equal to 0.4771. Antilog is equal to 3. Into this characteristic will become 10 to the power minus 4. You understood, sir? Hello?
Yes,
Yes,
sir.
sir.
Sir, let me take another case. Log k is equal to, say, 18.3991. 3979. Yes, sir. What is k equal to?
I think 10 to the power minus 8.
Subtract 1, it will become minus 19. Add 1, it will become plus 0.6021. Yes or no, sir? Hello?
Yes, sir.
What is antilog of 0.6021, sir?
4.
4. So I will write it as 4 into 10 to the power minus 19. So often in electrochemistry, they are asking what is log k, means directly you put answer. Rarely they ask what is k. What is k means you should convert the log value into value without log. Antilog you should see. Log k is equal to minus 14.4771. If they ask what is log k, you have no problem. But rarely they ask what is k. If they ask what is k, you should see antilog of it. To see antilog of it, you have to remember characteristic can be negative, but mantissa cannot be negative. When you got minus 13.5229, everything is negative. Therefore, I will convert this into positive by doing subtract 1, add 1. When you subtract 1, it will become one number more negative. This value will become positive. You should remember these log values. What log values you should remember? Always log 2 is equal to 0.3010. Always log 3 is 0.4771. Always log 4 is 0.6021. Always log 5 is 0.6990. Antilog of this is 5, antilog of this is 4, antilog of this is 3, antilog of this is 2. Are we very clear, sir, about it? Hello?
Yes.
Hello? That's what
Yes.
we get rarely in exam problems, but that difficult problems they are not asking. Okay, sir. Now I have very important message. Very, very important message. I have a cell like this, sir. I know its potential is minus 0.76 volts. I know this electrode potential is plus 0.34. What is E0 cell, sir? E right minus E left. What is its value, sir? Are we very clear? Hello? Hello, are we very clear about it, sir?
Yes, sir. Yes, sir.
Yes,
Now,
sir.
sir, I want to increase the voltage. I want to make it 1.159. What should I do? From Nernst equation, I know E cell is equal to E0 cell minus of 0.059 by N into log product ions concentration by reactant ion concentration. Do we know this, sir? Hello?
Yes, sir.
Sir, I want the cell potential to be 1.159. But I know standard cell potential is 1.10. Here N is 2 log product ions by reactant. Do you agree to this, sir? Hello?
Yes.
Hello, sir. Now, if I am bringing it here, it will become how much, sir? Yes, sir? Can you see it? Hello? Do you agree to this relation, master? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, now actually the log Zn plus 2 by Cu. Sir, thank you so much. Thank you so much. Thank you so much. But some students have gone. Oh, I feel bad. Actually, I took a while. Sir, we are discussing a very important problem, sir. In this problem, Zn by Zn plus 2, Cu plus 2 by Cu, it is minus 0.76, it is plus 0.34, and our E0 cell is actually equal to 1.10. But I want to have a cell whose potential is 1.159. So now what should I do? From Nernst equation, I know E cell is equal to E0 cell minus of 0.059 by N into log product ion by reactant ion concentration. Are you clean about it, sir? Hello?
Yes, sir.
Sir, in this case, if I bring this fellow here, E cell minus E0 cell is equal to minus of 0.059 by 2 into log Zn plus 2 by Cu plus 2. Agreed, sir? Hello?
Yes, sir.
Sir, if I rearrange it, I will be getting 0.059 is equal to minus of 0.059 by 2 into log K. Sir, what should be the value of log K, sir? This is true when log K value is equal to how much? This is true when log K is equal to how much, sir? Hello? Hello, we are all mathematics students. We have to identify the answer, sir. Log K must be how much, sir?
-2.
It should be equal to -2. Yes or no?
Yes,
sir.
Sir, log K is equal to -2 means K must be 10 to the power -2. Yes or no?
Yes, sir.
If K is equal to -2, then it means that K must be equal to 1 by 100.
Yes, sir.
Yes.
It means that the zinc ion concentration is 1 molar. The concentration of copper +2 must be equal to 100 molar. Yes or no?
Yes.
Hello? Or in other words, if zinc +2 ion concentration is 0.001 molar, what should be the concentration of copper +2, sir? Hello?
.1 molar.
Yes or no?
Yes, sir.
So the answer is the Zn +2 by Cu +2 ion concentrations are in the ratio like 0.001 by 0.1. Yes, sir?
Yes.
Remember, in a cell to increase cell potential, this product ion concentration should be as less as possible. The reactant ion concentration should be as much as possible. It should be more, it should be less. Then the cell potential will go up. Are we clear about it?
Yes.
Hello? Let us see this problem. I don't know whether it is really difficult for you. Sir, this is a cell. The cell potential standard condition is this much. I want a cell whose potential is more than this. It is more by 0.059. The increase in the cell potential I want is equal to 0.059. The increase in cell potential is always given according to Nernst equation equal to this. So, if I want the 0.059 is equal to minus 0.059 by 2 into log K must be equal to -2. Then only this is true. Log K is equal to -2 means K must be equal to 10 to the power -2 by 1. Yes or no, sir? 10 to the power -2 by 1 means it should be 1 by 100. If the concentration of zinc is 1 unit, the concentration of copper should be 100 times more. If the concentration of zinc is 0.001, then the concentration of copper should be 0.1. Are we very clear, sir? Hello?
Yes, sir.
This is the problem that appears in IIT means. In fact, they will give a graph like this. This is O, this is A, and this is your Zn +2 by Cu +2 ratio. Okay, sir? Here it is increasing. Means here it is what, sir? Decreasing. Yes or no, sir?
Yes, sir.
Now, what should be the decrease in this? What should be the ratio of Zn +2 by Zn? I mean, Zn +2 by Cu +2, when this increase in voltage corresponds to 0.05. If the voltage is increasing by 0.059, the ratio between Zn +2 by Cu +2 should become 1 by 100. Yes or no, sir? Hello?
Yes, sir.
Yes, sir.
So once I have seen in IIT Advanced a question like this, I will show you the test of such question in the exam to come, but they made a question like that. First of all, you think that you need variety of questions. Don't go for stereotype. I made one YouTube video about solubility product. I want you to kindly examine it. because already it is 8.5. Now I can't really take time to again explain that. But that is an interesting model. Here I have to explain one point. Sir, on x-axis, I have taken log K, sir. And it is our Daniel cell, that is Zn plus 2 by Zn salt bridge, sorry, Zn by Zn plus 2 salt bridge, copper plus 2 by copper. It is the voltage 1.1. Sir, if I am increasing log K value, what happens to the voltage? Will it increase or will it remain constant or will it decrease or will it become like this? What is the answer, sir?
It will decrease option C.
Option A, option B, option C, option D. What is your
Option
answer,
D,
sir?
sir. D.
D is right. Can you see it really? That is a question I have seen earlier. Unless you have clarity about non-stick equation, you really can't solve this type of problem. Please observe a video I have posted in YouTube to solve problems of this kind. Now I am going to talk to you about the electrode potentials for a minute. Sir, because time is ticking away, I have to quickly go to next model. You know that when current is passed through a wire, resistance experienced is directly proportional to length of the wire. Resistance is inversely proportional to cross-section area. Resistance is proportional to L by A. Resistance is equal to rho into L by A. Rho is called what, sir?
Resistivity.
And rho R is also equal to 1 by K into L by A, where reciprocal of rho, that is 1 by K, K is called conductivity. It implies care is equal to L by A. L by A means length of the electrode I am using divided by cross-sectional area of the electrode, which we are using in an electrochemical cell, is called cell constant. Whenever you have used any cell again and again, the cell constant remains same. Cell constant is always equal to specific conductance of the electrolyte I am taking, product with resistance I observe. Notice the K is called conductance due to 1 centimeter cube ions. K into volume of solution will give me the total conductance of solution. If I take 1 mole of any electrolyte, maybe in 1 liter, maybe in 100 liters, maybe in 1000 liters, the molar conductance is given by kV. And you know, volume is always equal to 1000 by molarity. So this is molar conductance at concentration C. If I dissolve 1 equivalent weight in any given volume, then its equivalent conductance is given by K into 1000 by concentration solution in normality. Now I want to solve an interesting problem. Look at this problem, sir. The resistance, please take down this problem. The resistance of a 0.2 molar solution is equal to 50 ohms. And its K is equal to 1.4 Siemens per meter. Now, the resistance of 0.5 molar solution in above cell is 280 ohms. What is the molar conductance of 0.5 molar solution? So that's the problem. For 0.2 molar solution, they gave me specific conductance. For 0.5 molar solution, they did not give me specific conductance. This is a standard IIT problem. Look at this problem once. Try to understand this problem. Check whether we can solve it. It is a lengthy problem, but nevertheless we try to do. Sir, first you understood there is a cell. In that cell, I have taken 0.2 molar solution of a particular salt. I recorded using a Wheatstone-Bridge formula that its resistance is 50 ohms. And the very same cell, when I have taken 0.2 molar solution, has a specific conductance conductance in every 1 meter distance between electrodes is found to be 1.4 Siemens per meter. When I take 0.5 molar solution in the same cell, its resistance is found to be 280 ohms. If I am increasing molarity, resistance is increasing. I want to know what is the molar conductance of second solution. Can you see it, sir? Hello? First, did you understand the problem? Let us solve only this problem and close our class. Sir, you understood the problem or not?
Understood.
Is the answer 500?
First, we have to understand the problem, then we can solve it later. I have taken solution 1. I have taken solution 2. It is 0.2 molar. It is 0.5 molar. Same volume. When I used here resistance, I found its resistance is equal to how much, sir? What is the resistance of it, sir? Hello?
3 ohms.
50 ohms. What is its resistance, sir? What is
280.
its specific conductance, sir?
1.4 Siemens per meter.
Its specific conductance they did not give. Its molar conductance they are asking. That's the problem. Sir, how can I find molar conductance of anything? Do I know molar conductance of anything is equal to K into 1000 by molarity? Do I know that, sir?
Yes.
So what is the molarity of this solution? Notice that molarity scale talks about how many moles of solute is dissolved in 1000 centimeter cube of solution. Do we know that molarity means number of moles of solute in 1000 centimeter cube solvent. That is 1 liter. Do you know that, sir? Hello? Hello?
Yes,
If I
sir.
dissolve 1 mole of any fellow in 1 liter or 1000 centimeter cube, that is called 1 molar. Molarity scale is based on how many moles of solute is there in 1000 centimeter cube. I want you to notice that very important relation. Have you noticed it, sir? Hello?
Yes, sir.
But they gave me, I know relation, molar conductance is equal to K into 1000 by molarity of solution. If molarity is in centimeter cube, moles per centimeter cube, K should also be in the units of Siemens per centimeter. Yes or no? Molarity scale is talking about number of moles in 1000 centimeter cube. My K should also be in Siemens per centimeter. Can we see it very clearly? Hello?
Yes.
Therefore, they gave me the specific conductance of first electrolyte as 1.4 Siemens per meter. I should convert into Siemens per centimeter. Can I convert it, sir? Hello?
Yes.
K is equal to 1.4 Siemens per meter, which is equal to 1.4 Siemens by 100 centimeters. Yes, sir? Yes, sir? Hello? 1 meter is equal to 100 centimeters. Do I know that?
Yes.
Yes, sir.
This is equal to 1.4 into 10 to the power minus 2 Siemens per centimeter. Are we very clear?
Yes, sir.
Now, sir, I know K into R is equal to L by A. Do we know this relation?
Yes, sir.
Yes.
So what is the cell constant in this case? 1 by 4 into 10 to the power minus 2 into resistance. What is the resistance of the
50.
first electrolyte? 50. This is the value of cell constant. I would say, I noticed that cell constant is equal to 1.4 into 10 to the power minus 2 into 50. Any problem, sir? Hello?
No, sir.
No, sir.
Now, when I used the very same cell, I noticed the resistance in second case is how much?
280.
280.
280 ohms.
280 ohms. You know, resistance is equal to 1 by K into L by A. Do I know that, sir?
Yes.
Do I know that relation?
Yes, sir.
Yes.
So in second cell, 280 is equal to 1 by K. I don't know specific conductance of second solution, but L by A value is same because I used the same cell. So can I find out what is K, sir? The specific conductance of second solution is equal to 1.4 into 10 to the power minus 2 into 50 by 280. Can you see it very clearly, ladies and gentlemen?
Yes, sir.
Yes.
So I know the specific conductance of second solution. Now, what is molar conductance, sir? Molar conductance is equal to K into 1000 by molarity of second solution. What is the K value in the previous slide, sir? Hello? What is the K value? 1.4 into 10 to the power minus 2 into 50.
0.00.
Yes?
Yes.
Yes,
Hello?
sir.
Please see. 1.4 into 10 to the power minus 2 into 50 by 280. Can you see it clearly?
Yes, sir.
This into 1000. What is the molarity of second solution, sir?
0.5.
So if I simplify, how much answer I will be getting, sir?
Five, sir.
Sir?
5.
5 Siemens centimeter square per mole.
Can I see it very clearly?
Yes.
Siemens centimeter square per mole. But they want answer in Siemens meter square per mole. How can I convert it to Siemens meter square per mole, sir? Hello?
Multiply
Hello?
with 10 power minus.
Sir, into uన్నా. Yes, sir. అమ్మ ఫోన్ నా దగ్గర ఉంది. నా దగ్గర ఉంది అమ్మ ఫోన్. If you allow 5 minutes, my problem will be over. I'll be back. Just allow 5 minutes. Sure, sure. Hello. Can you see it, sir? I want you to convert into Siemens meter square per mole. You know,
So divide by 10 to
to,
the 4.
to convert the centimeter into meter, I have to divide with what I should do, sir? You know that 100 centimeters is 1 meter. Do you know that, sir?
Yes, sir.
So centimeter square means centimeter into centimeter. 1 meter square is equal to 10 to the power 4 centimeter square. Yes or no? Hello?
Yes, sir.
Yes.
Hello? So now how should I convert it, sir? Tell me how to convert it.
So divide by 10 to the power 4. sir.
Yeah, I have to divide with 1 centimeter can be written as 10 to the power minus 2 meters. Yes, sir?
Yes.
Is equal to how much, sir? Is that fine?
Yes, sir.
That's all, Your Honor. See, check up what units they are using, accordingly you tell the answer. Okay?
Yes, sir.
But what is the unit of conductance? Is it Siemens centimeter square? Yes. Is it not so? So, check up this problem, how we have solved it. It is a bit lengthy problem. Normally in advance, they ask 1 or 2 such problems out of 20. 20 problems you have to do in 1 hour time. In that 1 hour time, you will have 1 or 2 problems which require 3 minutes time. Remaining 18 out of 20 problems usually they give. 18 will take each one half minute or 1 minute time, 18 minutes. 1 or 2 problems which will take 3 minutes, so 6 minutes. Roughly chemistry paper one can answer in 30-35 minutes. For physics you require more time, for maths you require more time. In chemistry paper you have usually, in physical chemistry, hardly 2 problems which are a bit tough. All other problems will be very easy, direct formula substitution. They are not particularly difficult. I try to upload one more video tomorrow on some problems, especially on Kohlrausch law. Look at this final problem. Just look at this problem. The molar conductance at infinite dilution of NaCl is X. The molar conductance of HCl at infinite dilution is Y. And the molar conductance of ammonium chloride at infinite dilution is Z. The molar conductance at infinite dilution of NaOH is P. Now, what is the molar conductance at infinite dilution of ammonium hydroxide? Sir, the molar conductance at infinite dilution of NaCl is X. Molar conductance at infinite dilution of HCl is Y. Molar conductance of infinite dilution of ammonium chloride is Z. The molar conductance at infinite dilution of NaOH is P. What is the molar conductance at infinite dilution of ammonium hydroxide? How you will do, sir? Hello, sir. Hello, how you will do, sir? Can you see that Z plus P minus X value is equal to the same? If I take Z, I am taking ammonium ion plus chloride ion. If I am taking P, I am taking Na plus ions and OH minus ions. From this, I can clearly see ammonium ions plus chloride ions plus sodium ions plus OH minus ions minus Na plus ions and Cl minus ions. Can you see, sir? It is minus Na plus minus Cl minus. Minus Cl minus plus Cl minus cancels. Minus Na plus cancels. You are left with ammonium hydroxide. According to Kohlrausch law, at infinite dilution, conductance offered by Na plus ions is not influenced by Cl minus ions. Conductance offered by H plus ions is not influenced by Cl minus ions. So on. Therefore, in order to get conductance of a desired electrolyte, I can add, subtract, multiply, divide, whatever the given values. Are we very clear about it? Hello?
Yes,
Hello?
Yes.
Let us see this problem. You want to know molar conductance at infinite dilution of acetic acid. You are given the conductance of HCl, X. You are given the conductance of CH3COONA, Y. And you are given conductance of NaCl, Z. What is the molar conductance at infinite dilution for acetic acid? How to
X
relate
plus
this?
Y minus Z.
X plus Y
Y
minus Z.
plus X minus Z.
Can you see it, sir?
Yes.
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 This type of question they are asking from Kohlrausch law. According to Kohlrausch law, at infinite dilution, conductance offered by one particular ion is independent of the other. Also, there are some problems on Kohlrausch law. For a strong electrolyte, the variation in conductance versus square root of concentration. If I am adding water, the concentration is decreasing, conductance is increasing. When the C tends to 0 here, the maximum conductance which I notice is called molar conductance at infinite dilution. Always I notice conductance at concentration C divided by conductance at infinite dilution gives me the degree of dissociation alpha. For a weak acid like acetic acid, if I know alpha value, then I can find out how many H plus ions the acid can give. Notice the number of H plus ions an acid can give is always equal to C alpha for a weak acid, where C is the concentration, alpha is the degree of dissociation. So to know the H plus ions given by any weak acid, I should know what is C alpha. By alpha, I mean what is the extent of dissociation the acid has. Therefore, to know alpha, I should know ratio between conductance of given concentration by conductance at infinite dilution. For a strong electrolyte, I can easily find it by extrapolating. But for strong electrolyte, this data is not needed. It is needed for weak electrolyte. For weak electrolyte, the variation in conductance is not following a straight line. So for weak electrolyte, this Arrhenius relation is not applicable. For strong electrolyte, it is applicable. But I need it for weak electrolyte. Therefore, I can't use the graphical method to molar conductance at infinite dilution for weak electrolyte. For weak electrolyte, I can find molar conductance at infinite dilution using Kohlrausch law. I measure the conductance for strong electrolyte solutions. I add, subtract, and do whatever, get the molar conductance at infinite dilution. From this value, I can always find alpha is equal to molar conductance at concentration C by molar conductance at infinite dilution. Once I know alpha value, I can simply multiply the alpha with C, and then I can get H plus ion. If I know H plus ion concentration, pH is equal to minus log of H plus. Often they are giving me this type of problems. I try to solve one or two problems and upload them in YouTube. Please see your textbook for more data. Thank you. I am closing the class. Any doubts, sir? Hello?
No, sir.
Thank you very much. Sorry, this class is a bit troublesome, but anyway, we have to do it. Thank you very much.